If you work out at the gym, you should download.
Drink alcoholic. Business means that I'm not that responsible for. So that's that he tries to drown us in alcohol and get drunk. Now he wants to return home but is unable to walk straight. The rider will steps forward and the walking runs to backward. Formerly, the first step in movement and third step in the second movement we move one step backward. In the third step we move forward, three steps forward, in four steps one step backward. So how far do you Yeah, I guess this question is pretty easy. I see pattern. What? Okay. Okay. So okay, first one. Then this can be let's submit this. I guess this can be correct. €7.13 put. Okay. 7.25. Third step, there's no 7 steps. Okay, my observation is wrong. Cannot do directly. The sum of k over all distances does not accelerate. Accelerate instance and let's write in copy. This one is finding out that it's responsible for that. So this is transfer times. So I'll go and get your time. I'm going to distribute more by you can move that forward. I will switch to forward. For tracking the blocking range. Formally, in the first second, to forward and backward. Okay, I think this problem will be easy. And like we need to not just for this I use for loops. Okay, I'm back. I was settling some. Okay, now start. Drink alcoholic. First, second. So there are two steps mainly. If number is like if number is odd, 3 would get plus. I guess this can be true. Yeah, we made it. Let's go to the next question. And like in this question, the question is pretty straightforward. Like formally, in the first second, he moved 3 steps forward. In the second, he moves 1 step backward. Like what I use in this problem is that I see a pattern or logic. If the time we know the time is starting from like 5, and 5 will be minus 5 1, then 4. If time is divisible by 2, means by if time is even, we need to add 3 steps forward, and if time is odd, we need to minus 1 from the final step. So and in last we print the final step, then our answer got expected. That's it. As you know, now let's go to the next question. Stephen Einstein. And now let's move to another question. In this question, let's write into copy. Question number 2. Suppose Sev is stuck on an island, and currently he has X unit. He's stuck on an island and he has currently X unit. X unit of food supply, as unit to be of supply, food supply. Food supply. Sorry guys for interruption. My cat is coming in my stream, so that's why. So in Iceland, X unit of supply, X unit of food supply, and Y units of water supply. Y unit of water supply, CP-31 of water supply, and in total that he could collect. This is the total amount he can collect from that Iceland. He needs X R unit of food supply and Y R unit of water supply per day at minimal to have sufficient energy to build a boat from the wood. Also to live for another day. Assuming it takes exactly 3 days to build boats and reach the store. Till weather sufficient amount of supply to be able to reach the store by building the boat. Input. Okay, I guess we need to print as such no. If so, the input cases are T, XY, XR, YR, this. So X and Y, X equal to total amount of food supply, SUPPL supply, water supply, per day food, per day water you need to consume, and number of days to build, so per day, if in minutes, per day 1 liter of water, let's see the test cases. Input cases. Inputs are 4, 2, 1, 1, 1. So number of days to build boat is 1. Per day water 1 liter, per day food 1 kg less consumed, and 4 by 2. So per you have total 4 kg of food, 2 liter of water. So per day. So if 4 by 2 is 4 by 1, let's do 4 by 1 equal to 4. 4 is greater than number of days, and okay, and 2 by 1 is greater than 1, then our answer will be as else no. Okay, let's write a code. And the X, Y, A, B, D, CIN, X, Y, A, B, D. Let's find and what is the total per days. So answer can come in like point, decimal, so we need to use double. Let's say and X inputs equal to number of foods equal to xy number of food equal to a, and let's categorize with towel. And water equal to double y by xb. If n food greater or equal to d and water greater or equal to d, count. Let's see if the code is correct or not. Yeah, the code is correct and we did it. Previous one. Okay guys, let's move to Codeforces. I'm practicing from I'm practicing on CP-31 from from this guy, P ranks Agarwal. Okay, let's solve. Let's do this question of Codeforces. I already tried this question actually, but I can't do. Let's do again. Let's write it. Copy what it's saying. Filmus is busy after his last contest, as now he has to deal with many Halloweens all over the world. He stored them inside ant boxes, and each of which has some numbers AI written on Their friend is busy after his last concert, as now he has to deliver many Halloweens all over the world. All over the world, he stored them inside ant boxes. Now, first question given. Stored them inside ant boxes. So variable equal to ant boxes, okay. And which of the and each of which has some number. And in order to as AI written on it, we wanted to sort them in non-decreasing order based on their numbers. However, this machine works in a strange way. It can only reverse any solid string boxes with length at most k. So we wanted to decrease. We wanted to sort them in non-decreasing order. So it means non-decreasing order means that let's see, like we have 1, 2, 3. It is correct, but 2, 1, 3 is not correct because it is decreasing sometimes. However, this machine works in a strange way. It can only reverse any sub-array. It can reverse. Sub-array of boxes with length at most k. So it can reverse any sub-array of boxes with length at most k. Find if it is possible to sort the boxes using all numbers. Find if it is possible to sort them the boxes using any number of reverse array. Reversing a sub-array means choosing two indices I and j, where one is lesser or equal to I is lesser or equal to j is lesser or equal to n, and changing the array a1, a2 and a and 2, a1, a2 to ai minus 1, a j minus 1, ai is j plus 1 equal to the length of sub-array is then j minus I plus 1. The length of after reversing a sub-array means choosing two indices I and j. Reversing a sub-array means choosing choosing two indices I and j. And क्यों नंबर से I and keyword changes a1, a2, a3 to a and some also 2. अब यहाँ से मैं 2 कहाँ से मतलब a1, a2, a3, a2, ai minus 1, aj minus 1, n minus 1, an. Length was inside. Length of sub-array is like j minus I plus 1. The first line contains single integer, the number of test cases. The first line contains single integer t, and the number of test cases was the number of each test case consists of 2 lines k and n. Okay, we need to use long in this. Because the length, because in int value we can store 10 to the power 9 the number written on each boxes. So let's check our test cases. First test case 3, 2 and 1, 2, 3. We can see like the array is already in non-decreasing order, so we need to so it is always as. Okay, but how to check if they are all sorted in the order where there is non-decreasing, I mean if they are non-decreasing? The first line of each test case contains two integers n and k, the number of boxes and the length of the maximum reverse that Thafunas can make. The number of boxes and the length of maximum reversing Thafunas can make. Okay. The second line contains n integers a1, a2, a3. So this 3 is n and this is k. The maximum reverse value that we can, the maximum boxes of length of the maximum reverse that Thanos can make. Okay. So first answer is true, but how to know if they are all in non-decreasing order? For this, we can write code n equal to tn, and we know we have like n equal to k value taken as c n and k, and we can take vector int and now we can do for loops. This is usual as before, and I++. Now from this we can take scene equal to I. Now after this we can do another code equal to 0 as equal to n I++. We can iterate from this. Then for checking if all numbers are in non-decreasing order, we can check if as you know, in 9 also there is non-decreasing order for sure. One, two, three. 1, 2, 3. We need to check if we are if we are greater than n-1 I++, then C++, this we can all our let's say if first is correct, only first. There we go. expected to know like first answer is correct, then else. But this వరకు కొన్ని సెన్స్ మనం ఉన్నాం, this వరకు కొన్ని సెన్స్ మనం ఉన్నాం. ఇప్పుడు I plus the power. Let's see. Why the answer is coming too far? We are expected from like again where I did mistake. Like for this, what can be the answer? In the first two test cases, the boxes are already sorted in non-decreasing order. So let's find the pattern from this. 1, 2, 3, 9, 9, 6, 4, 2, 1, 6, 4, 2, 1, 6, 4, 2, 1, 6, 4, 2, 1, 6, 4, 2, 1. There are 4, so both are equal. You can do that. 1, 3. Or we can say that if number is 1 lesser than, value of k, like of also k, this one is not correct. I read that you are trying first try instead of action. That's also good. First is you are printing as. You are visual setting. Second is I plus k. What does I plus k division? I equal to 1, equal to 3, I plus equal to 7. What does it mean? Maximum reversal in one something like the biggest thing. Forget the number, think about the operation. You are allowed to reverse any survivor of length that means ask yourself k equal to what reverse are possible? Looks like 7 reverse 7, nothing 7. So if k equal to 1, then since the array is 2, now you can reverse 3 and 5. Okay. Yeah, I guess my thinking is correct. Let's try the code. this we need to take LL. Test cases, test report test cases, we need to take decimals and y2 minus LL equal to xn kcim, no xn not k, cim kcim, if n minus 1 if n is greater than 2, if n is greater than 1 and n minus 1 is equal k, we will derive over if n equal if n equal k, if n equal k slash the test cases like मेरा अनुसार जैसे 3s or 2s, 1s or 2s, 3s. So n minus 1 equal to k so we can reverse it. So we can reverse it. So 2 equal to 2, so as answer. Now 3 equal to 1, 3 equal to 1, but if all the sub array now this is nonsense. Now this not correct, for sure, not correct. Petrol or let's take boolean bool equal to, till now it's true, now for int I equal to we can do if ai we can like if the maximum value is increasing order, we can true it whenever it becomes false. Whenever it becomes false, boolean true set. If always put it in here. True. About true novel energy. If AI is the true novel energy, we can do. What you can do? About like if yeah. 1 and the 2 and the other is done. If 1 cursor 1 and the 2 and the 2 and the 2 and the 2 you want the answer AI the positive true answer true answer or else अब लमाना हाम्रो correct छैन then what we need to find if अब A भन्दा जति ठुलो एलिमेन्ट i+1 मा छ जस्तै अब A भन्दा ठुलो एलिमेन्ट कस्तो हुन्छ if ai greater or equal to a1 plus i plus 1 i plus 2 i plus 1 then what do you need to think let's read question again guys in this section. Reversing a subarray means choosing two indices Reversing a subarray means choosing two indices I and j where one greater or equal to I lesser or equal to j lesser or equal to n, and changing the array a1 a2 an2 a1 a2 ai minus 1 aj minus 1 aj plus 1 an minus 1 an. Thus, the length of subarray is then j minus 1 I plus 1 input. What would be the input? Input cases to आपने था सर for each test case print out even था सर let's implement the code if ai greater or equal to a I plus 1 मतलब mathematics is a sorted our first if is already sorted, because if all element in that sub array are like equal or in non-decreasing order, that will be always true. Are we already right? What if that not a case? Like, what if that is not true? Then what we need to find? Well, like, then else, if I'm thinking like this, if in we already in C and D equal to 0, if we find any of number which is in decreasing order, we can take them as C and D plus plus, and we can compare it to with K, like with the most reversing. Then if any number greater than this second test cases, if AI if AI greater or equal to AI plus 1, let's check the sub-array. Like 6 4 2 1 6 4 2 1 6 4 2 1. See, we can see from first there is like non-decreasing order greater or equal to, so this will be 1 also, this will be 2, and this will be 3. Also, if there is 3 numbers, or if there are 3 if there are 3 decreasing order, then we can say CNT plus CNT equal to plus 1. Then if K greater or equal to CNT, as else no. अब तुम्हें एवढा किसी से उसको जाना है 10 से 3 से 830 से 14 से 10 से 3 से 830 से 40 से okay guys, I'll go to restroom. This one, I'll go to restroom. So Guys, we are back. So not correct. You're decreasing order myself, so we don't need to take this. So this will be correct. This is equal to 14. 4 is equal to this. This is decreasing order, so we can reverse this. Plus 1 equal to 3. So okay, I think I found some logic. Let's implant this logic. See. Same plus same. No. CMD plus once again, then 2. I equal to true. Or greater than or equal to C and D. Count codec syntax indel else let's see if this is correct or not. If this is incorrect, I am stopping this. I mean, when it will be this and equal to be true. Let's see now. Okay, we got it right. Let's submit this. How is set? How this is correct? Please. Okay, this fails in second test cases. Okay, guys. For this question, I am putting this much time in it. So let's also solve this question. Based on ground property. Where would those one? But Is the answer really no? Okay. If k equal to 1, what equation is possible? If k equal to 1, what operation are possible? Only reverse a string of length 1. Can be never change by now. If you can reverse any solution of length 2 and add it to I can also do this. So if k equal, the array must be already sorted. If k greater or equal to 2, then you can reverse any permutation can be evaluation sorted. So the answer is no longer depends on real value. You are one of the reason I am trying to write everything. As if k equal to 1, you can reverse one element, so nothing changes. The array can be sorted only if it is already sorted. If k equal to greater than equal to 2, can you reverse any two neighboring elements? So length of array of length to reversing to neighboring element is just right with neighboring side. So here is the simple thing. If k equal to 1, you can only reverse. If k greater than that's the trick. Equal to print as for every array. Print as for every array. Print as for every array. K greater than equal to 2. K equal 1. Print as if only so your program only need to check two cases. K equal 1. Equal 1. If k is equal 1, we can solve is implementation to a problem that hide one key object that sometimes you can code perfectly and still fail. Imagine the array is 4, 3, 2. Case 1, k equal to 1. You can only reverse it. 4, 3, 2, 1. Does anything change? Must be already sorted. That's true because a single element array is already sorted, but that's not the important condition in the problem. The key condition is k equal 1 because so the entire solution becomes if k equal 1. Check if array is already sorted. And because k is the maximum length of the variable, if the array is already sorted as if not. If already decided equal to equal to 10 equal to this is correct. Okay. Outside. Let's do this. let's submit this. I guess this time my code can be correct. Let's see. Let's check. Okay, it's running. Where did it? Suppose the array one that already अच्छा else break else break. Now let's check now. Now let's see this time. Holy. Okay, man. Where did I make mistake? Another unit. Instead of starting with n equal to 2, usually the answer is as ask y is frustrated. Instead of using this, ask yourself, should I assume the array is sorted first? Usually the answer is as okay, then let's take this true always. I equal to false and break. This is also got fast, but let's see if the excellence. Okay, we made it, guys. After a long time we made it. We almost spent 1 hour 15 minutes in this question for solving. Yeah, I take some hints, but for 60 minutes I did not take anything. Okay, finally, man, after 1 hour 15 minutes of closing. Time thinking about what Q actually means. One time improvement. Let's see. Bro, this is the methodology, correct? array is sorted. Then if k equal 1, if k equal 1, k equal 1, check whether the array is already sorted. Check whether sorted one assumes if you find one decreasing order where answer become no, then else wait. Yeah, then true signs k greater or equal to always true. So this works too. So tiny improvement, you don't need else equal to true because A is already true. You can even do okay, after how much attempt? 1 attempt, 2 attempt, 3 attempt, and 4 attempt. We got it right. In first, let's see the tutorial of this. Almost 14 drops on. This is my Codeforces username. If you want to become friend, add me. And if k is greater or equal to addition, okay. If the array is already sorted or k greater than 1, then there is always a way reverse of size 2. Swipe consecutive elements, else it is possible signs k equal to 1. Okay, how did it done? If sorted greater than, okay, this is very optimized code. Let's try to solve this. Okay, man. For solving this. Okay, this.
Hello everyone, my name is Viraj, and today we'll be looking at the very first problem from the CP-31 sheet by TAV eliminators under the
So hello guys, welcome back to this video, and from this video we are going to start solving one very interesting concept by Priyansh, who is ICPC World Finalist and Master of Codeforces. So we are going to start solving of this rating 8. Is busy after his last contest. So let's see. So this is all. However, his machine works in a strange way. It can only reverse.
Hello everyone, my name is Viraj, and today we'll be looking at the very first problem from the CP. Hello everyone, my name is Viraj, and today we'll be looking at the very first problem from the CP-31 sheet by TAV eliminators under the 800 rated questions. Let's begin. So I'll be moving on to the CP-31 sheet to find my problems. I have ticked off the 800 rated parameter over here, and I can see my clickable links. Here is my first problem. Let's open this. Halloumi boxes. All right, let's see the problem. Great. Now let us look at the next page. What should we now think, and how should we finally approach this problem? All right, so now this problem is about yes and no, correct? I have to print somewhere in yes, somewhere in no. So it makes sense that I will have some cases, right? Some case making would be very great to begin with. All right, so let's try to make some very, very simple cases. So of course I have the array, and that array will have, in my head, it can have one of the two nature. All right, let's discuss what two natures am I talking about. So I'll draw these two cases. One nature will obviously be the array can be sorted. As soon as the array is given to you, you realize, okay, the array is already sorted. And the other nature, of course, becomes the array is unsorted. These are the only two viable cases I can distribute my array in. This is case 1, this is case 2. Why have I done this is because I know inside my head one thing for sure. If I look at case 1, if the array is already sorted, can I say that my answer is already yes? Correct. I can. Why? Makes sense. And the array will have, in my head, it can have one of the two nature. All right. Let's discuss what two natures am I talking about. So I'll draw these two cases. One nature will obviously be the array can be sorted. As soon as the array is given to you, you realize, okay, the array is already sorted. And the other nature, of course, becomes the array is unsorted. These are the only two viable cases I can distribute my array in. This is case 1, this is case 2. Why have I done this is because I know inside my head one thing for sure. If I look at case 1, if the array is already sorted, can I say that my answer is already yes? Correct. I can. Why? Makes sense, right? If the array is already sorted and you were asked how many, like not how many, sorry, you were asked, can you actually sort this? If the array is already sorted, you can obviously sort this, right? You can just print the array itself and yes, it's sorted. So I know if the array is already sorted, I don't need to do anything. However n is given, however k is given, whatever is the array, if it's sorted, answer is blind eye, it's yes. Correct. So I know I can create a yes over answer is. If I look at case 1, if the array is already sorted, can I say that my answer is already yes? Correct. I can. Why? Makes sense, right? If the array is already sorted and you were asked how many, like not how many, sorry, you were asked, can you actually sort this? If the array is already sorted, you can obviously sort this, right? You can just print the array itself and yes, it's sorted. So I know if the array is already sorted, I don't need to do anything. However n is given, however k is given, whatever is the array, if it's sorted, answer is blind eye, it's yes. Correct. So I know I can create a yes over here. I can say yes to this particular solution and I'll be good to go. That means all that is left for me to discuss is what happens if the array is unsorted. If the array is unsorted, of course I want to do something. Correct. Of course I want to approach this problem in such a way where I can actually do something on an unsorted array, because for sorted arrays, answer is always yes. So let's discuss this. I'll again bifurcate this into two cases. Alright, I'll again bifurcate this into two cases. We'll see what cases am I talking about. So, of course, when the array is unsorted, you have to make some changes. To make some changes, you are given the operation of reversing the subarray. And there is a parameter that's fixed to that particular power that has been given to you. That parameter is k. So that means there is some dependency on k. I know that. Let's start off with the very base case of k, and maybe I can formulate my answer from there. So let's think about very basic. What if k is 1? What if k is 1 given to you? If k is given 1 to you, let's try to analyze this. So I'll take up the test case again. You have this array over here. Array is 6, 4, 2, and 1. Now, if you have been given the array that looks like 6, 4, 2, and 1, this is definitely unsorted. You know very well this is unsorted. Now, because this array is unsorted, you want to sort it. What is the physical meaning of sorting? You understand that some element which is not at its desired location has to go to its desired location. That means 6 over here technically should be at the very last, since it's the largest element. So after sorting, I know 6 goes to the very last element. 1, let's say, has to be at the very first place. 4 has to be at the third place. 2 has to be at the second place. So you know there is some element in this array which needs to be at some place, but currently it's not. So I want to make it go to that place. The problem over here is, remember, I have been given k equals to 1. I have been given k equals to 1. Now if k is 1, essentially that means you can only take segments of at most k length. And k being 1, either you don't take any segment, that's 0 length, or you take a segment that's only of 1 length. Now 1 length segment simply means the number itself. So if I take this segment like 6, or like segment like 4, or 2, or 1, what essentially happens? What happens when you reverse an sub-array of size 1? The element doesn't change its location, it remains there. So if I want to reverse this segment, 6 still remains over here. If I reverse this segment, 4 still remains over here. If I reverse this segment, 2 still remains over here, and so on, so on, so on. And remember, I want to shift 6 somewhere. I want to shift 4 somewhere. Am I being able to do that? Or in a very generalized case, can I say that if k is given 1 to me, I have the power to shift any element from anywhere to anywhere that I want? No, I absolutely don't have that power. That means if k is 1 and the array is unsorted, can I say that the answer is always no? Yes, I can do that because it makes sense. I did not even have the power to shift any element from any position to any position. How will I actually make my array from unsorted to sorted? Not at all possible. Great, I hope this idea is clear. Now let's move on. Now since we discussed k equals to 1, the other case is going to be cases where I think k is 2, 3, 4 and so on. So let's bring up a generalized case in this. What happens when k is greater than 1? Alright, so let's look at that one by one. We'll see over here. I again take the same case and I'll rub it over here. I'll say, okay, what happens when k became 2? That means you had the power to swap, or you can say reverse, a sub-array of at most 2 length. Now at most 2 means 0, 1 or 2. Now 0 is of course not beneficial. 1 we just saw was not at all beneficial. What about 2? What happens when you select a segment of 2 size? Let's say I pick up 6 and 4. Essentially when I say I reverse this array of 6 and 4, I know that the 4 goes to this location and 6 goes to this location. And what essentially has happened over here, you can see that in a 2-size subarray, indirectly the elements have swapped their places. Can I say 4 came over here and 6 went over here? Yes, I can say that. Similarly, if I would have picked up 4 and 2, 2 would have come over here, 4 would have gone over here, and so on, so on, so on. Now, how is this beneficial? Let's start thinking. Can I say that for k equals to 2, do I get the power to place any element from any location to any location that I want? Let's see. Currently over here, let's imagine that you want to shift k, not k, 6 at the location that is over here. That's the last location. Of course, I can do that. How? Let's imagine. What if I select this segment first? I reverse this becomes 4 and this becomes 6. Let's write this down. So this becomes 4, 6, 2 and 1. Let's say I pick up these next two elements. So what happens this? This is 4, this is 2, this is 6 and this is 1. How about these two elements now? This is 4, this is 2, this is 1 and this is 6. Voila. Can I say that by using a 2-sized segment, I have finally made 6 go to a location where I finally wanted to go? Yes, I desired the 6 to be over here and yes, I have done that. What about next part? Now that 6 has reached its desired location, can you argue in the same order that if you want to make 4 go to its desired location, as in now the array looks like this, so can you say if I want to make 4 go to its desired location, that in this case is at the third location, can I do the same thing? Can I start taking up 2-2-side segments, let's say 4, 2, swapped, 2, 1, swapped, and will that make my 4 go over there? Of course. Let's say if you take up the first segment, this would transition to look like 2, 4, 1 and 6. Then you take up these two numbers as a segment and this becomes 2, 1, 4 and 6 and so on. Next time, if I take up the possibility to shift 2 to its desired location, that is at this place, what do I essentially do? I will simply take these two segments, this one segment of these two numbers, 2 and 1, and this becomes 1, 2, 4 and 6. And good to go. Am I good to go? Yes, I have sorted the array in a non-decreasing or an increasing order, which means that by taking 2 lengthed segments, I am having the power to somehow shift any element to any other place where I desire, and this power is indirectly helping me to say that yes, I can sort the array if it is unsorted, and if I am taking k equals to 2 every time, as in if I'm always selecting 2 lengthed segments, I'll be good to go. I can sort any unsorted array in whatever number of operations I want, and since number of operations is not bothered by me, the full and final answer is basically, can you sort it? I can say answer is yes, and so on. Alright, so this makes sense. Now, let's write this idea. I'll write this idea over here so that it becomes clear. If the power to make any element move from current position, let's say I'll call this pause, to desired position in this way. For K2, I know that I can say the answer is I blind always yes. Alright, so in this case I just discussed for K equals to 2, so I'll say answer is always yes. That means you can I always make sure it is already sorted? No, because if it's unsorted and K is 1, you never have the power to shift any element from any location. How will you sort it? Not possible. Be a printer. No, I'm good. Alright, so now what we'll do is we'll quickly look at the code part to understand how can we inculcate this whole idea into implementation and code. Alright, so this is going to be the code for this. Let's see. Very simple. I have taken the test cases, ran a while loop, and finally went inside every test case. I now am taking input, taking n, taking k, taking the input of n k, declared a vector, and then taking that vector as input. So this up till this is all about taking inputs. Now moving on. What I've done is I've created a copy of this array. So by simply writing copy a, that's a variable name I take, I said copy a equals to a. That means now copy a stores exactly a as it is in a copy format. And then I'm going to call an STL function of sort and sort this copy a from start to end. This creates a sorted a indirectly for me that is now visible in copy of a vector. And why am I doing this? Because I want to check whether the initial array was sorted or not. So how do I check that? I'll say, is my copy of a, that is the sorted a itself, equal to the initial a, that's a itself. If it's equal, or if k greater than 1, in both two cases, remember, I wanted to print a yes. So I'll say, okay, if copy is equal to 1, copy of a is equal to a, or k is greater than 1, I know I will print a yes. Else, this case is only when I say array is unsorted and k was 1. In this case, I print a no. And I'll be good. Alright, so this definitely passes the sample cases, and it's going to pass the correct all the cases, and get you an AC on Codeforces. Alright, so let us look at the time complexity now quickly. Now as we discussed, this taking loop of the array input itself, this is n order, correct? Now you are creating a copy of the array. This can be also said of n order because this requires copying each element every time. And then this STL function runs in the backend in n log n order. So you can say this is n log n, where n again is the size of this array. And then these are simple checks. This check, however, since you're checking the equivalency between two arrays, this would be taking an n order again, because in the backend there will be something like running a loop and simply checking element 1 by 1 and 1 by 1. So I can say this is again a check of n order, and I'll be good to go. So overall, now that I have written down the complexity of each and every possible operation that we are doing, if I write the final time complexity, I would be required to take the highest order in this case, which means I are required to take n log n, since n log n is the superseding term as compared to everything else. And now this definitely works. Why? Because I know I have a 100 size of maximum n. That means this would be something like log, again this is log base 2, and this would be 100 log base 2, or of 100 you can say, which essentially would mean something like 100 into 7, like 100 log base 2 of 100 is approximately 7 to 8 iterations. So this would somewhere go to 700 iterations, which is again good to go, of course, because I know this is well within my boundaries. I had a maximum limit of something like 10 power 6 operations we discussed per test case, but in this case per test case I'm only taking 700 iterations. All great. What about space? Of course, I'm dependent on the space when I'm taking a copy of this array, and if you would have also considered the space for the input itself, so you can say space is dependent on the size of the array, which is again in worst case O of 100, so you can say 100 size space. Again, we can just avoid to report it like this. O of n would be a good parameter to report on the basis of space. Again, within my boundaries, definitely getting an accepted solution, not a failure at all. Alright, so this is what wraps up our whole problem, and now we have realized how we can solve yes and no cases by case making. You can understand that, okay, I wanted to do this, hence the answer was yes. If this was already there, the answer was no, and so on, so on, so on. Alright, so I hope you liked the video. Thank you for watching.
Oh guys, I've seen the solution. Let's try this again, and let's try this again. And define array long. Array equal to nk. And is okay. Vector for bowl. Okay, can do two. Even one. Yeah, equal to plus 1 and second and if okay or if delta is equal to 2, okay, write this D. Hello guys, let's. Okay, I'm back. Let's start next question. This is a line trip. Question number 2. Line trip that there's road. Ridiculous math. Everyone gets it. Even this is a road which can lead. This is a road that can be represented as a number line. You are located in the point 0. Point 0 of the number line, and you want to travel from point 0 to point X. Traveling 0 to X point. Okay, and back to the point. Also, you travel by car, which spend 1 liter of gasoline per unit of distance traveled. You travel by car. Travel by car, which spend 1 liter per 1 unit of distance. Spend 1 liter equal to 1 unit of distance traveled. When you start at the point 0, your car is fully filled. Its gas tank contains the maximum possible amount of fuel. Starting 0, car is fully full. In a theoretical limit, I see a limit, LIM as a limit. There are n gases. There are n gas stations. So number of gas stations are 2. The number of gas stations are n. Located in point. Located in point A1, A2, A3 to AN. When you arrive at a gas station, you fully refill your car. Know that. When gas station only, gas also no in 0 and X point, no gas station, no gas stations are there. You have to calculate the minimum possible volume. You have to calculate minimum possible volume of the gas tank in your car. find minimum possible volume of the gas tank. Gas tank in your car that will allow you to travel from the point B. Find the minimum possible volume of the gas tanks in your car that will allow you to travel from point that will allow you to travel from point 0 to point X, then point 0. The first line contains one integer t. The second line contains, the first line contains to nx, n here number of gas station answer, okay, x one here, x point to reach. In the second test case x1 का use हुआ है x1 minus 3 of 7 1 2 5 मतलब एउटा 1 नम्बरमा छ ग्यास स्टेसन 0 मा 1 मा छ त्यसपछि 2 मा छ त्यसपछि 5 मा छ अनि x.7 मतलब एक ग्याप पछि एउटाको 2 छ एउटाको 3 छ एउटाको 3. So if the gas has in the first test cases of the example, if the car has a gas tank of 4 liter, you can travel to X and back. So you have to so you can travel to X and back as follows. Travel to point 1, then your car gas tank contains 3 liter of fuel. Refuel at the point 1, then your car tank contains 4 liter. Okay. Refuel at point 2, then 3 liter remaining. 3 liter of your gas tank contains 3 liter of fuel. Refuel at your car tank contains 4 liter of fuel. यस्तो धेरै हुन्छ. You can travel to greedy. अब मसँग 4 लिटरको ट्याङ्क छ भने चाहिँ टेस्ट केस ल टेस्ट केसेस if I had like 3 7 1 2 5 just use 3 to 7 1 2 5. अब if 4 लिटर का हमने थ्योरेटिकल लिमिट छ हैन जस्तै हामीले 2 लागेको हुन्छ जस्तै 1 देखि 2 सम्म जान्छ त्यसमा 3 पोइन्ट भएको 3 पोइन्ट आएको छ 3 I guess in this case we then need to find the minimum possible volume of. So we can say there are many possible values in this. अब एक रस 10 से 7 से बनी 7 में वैल्यू नहीं है 1 to 5 में 3 का से चाहिए मैक्सिमम माइनस मिनिमम आए और 5 माइनस 2 अंदर भी 3 हो जाए you got it let's try this into pieces. What is 5? 5 people are watching the video. ID. Oh, this is 3 minus 6 है, 3 minus 6 है, 5 है, तो 6 minus 5 हो गया आंसर 8 प्लस 2 10 है। नेक्स्ट पेज सेम है जो चलेगा। इसलिए हम सम बनाएंगे। टोटल सम माइनस एक 10 था, 10 बटा 7 बटा 3 बचे 3 प्लस 10। I'm located at point 0 में located है। नंबर लाइन को 0 लोकेटेड है। ये मेरा x वैल्यू है, x वैल्यू तो कितना नंबर है। नेक्स्ट सेकेंड रो उसमें डिस्टेंस पता हुआ है, कति क्लोज है दूसरा डिस्टेंस 3 मीटर डिस्टेंस है 4 और 6 करेक्ट। एउटा डिस्टेंस दुईटा डिस्टेंस तीनटा नहीं है, एउटा दुईटा डिस्टेंस 5 minus 2 3 हुन्छ, 3 हुन्छ 3 1 मैक्स 3 है। अब 3 6 1 5 3 What is the maximum distance I need to travel without looking? For this type of problem, what is the maximum distance I can travel without looking? Because you think that you must cover the largest gap. Going forward like, but at the end, after reaching X, there is no station. So you need to return from X. B1. And the distance is from the time to 5 meters. Figure one out, So last station minus max value करेंगे, सबको चेक करूँगा। 7 minus 5 करेंगे, आंसर आए 2। अब 2 चोटी जानुपर्छ, त्यसले मल्टिप्लाई गरेर 4 आन्सर आयो। अब 6 minus 5 equal to 1, 1 multiplied by 2 equal to 2 liters आयो। तर मिनिमम भ्यालु के छ यार, लार्जेस्ट डिस्टेन्स कति छ हाम्रो? लार्जेस्ट डिस्टेन्स कति छ? 3 छ। लार्जेस्ट डिस्टेन्स 3 छ। अब 10 र 7 को बीचमा लार्जेस्ट डिस्टेन्स कति छ? 3 छ। तर फेरि 3 मल्टिप्लाई 2 बढीमा 6 छ। तर फेरि 0 देखि 7 को डिस्टेन्स कति छ? 7 छ। सो आई गेस मैले हल्का त बुझेँ, हल्का बुझेँ गाइज। पासमा हामी आइट्रेट गऱ्यौँ, नमानौँ 1 गऱ्यौँ, 2 गऱ्यौँ, 5 गऱ्यौँ। हामीले 5 सम्म आइट्रेट गऱ्यौँ, भ्यालु पनि निकाल्यौँ। 2 minus 5 का एब्सोल्युट भ्यालु निकाल्यौँ, इक्वल टु 3 आयो। बट एट द एन्ड if 3 र 5 को लागि पछि पनि स्वाइप गर्न सकिन्छ किन? पछि पनि स्वाइप गर्न सकिन्छ। सो सुरुमा हामी यति लाइनबाट म्याक्सिमम भ्यालु निकाल्यौँ, यति लाइनबाट म्याक्सिमम भ्यालु निकाल्यौँ, त्यसपछि x को भ्यालु निकाल्यौँ, x को मतलब 2 हो। इफ 2 क्यारेक्टर छ भने त्यो गर्नु भनेको इफ ai greater than greater than if into power I current and max one down. Max will be current equal to AI. अब हामीलाई केसको डिस्टेन्स चाहिन्छ एउटा अब हामीलाई केसको डिस्टेन्स 0 देखि 7 को डिस्टेन्स एउटा फाइन्ड गर्नुपर्छ this is equal to as you know we are moving in number line, so number line 2 multiplied by mx minus mx plus x minus mx divided by आना चाहिए देखते लास्ट को डिस्टेंस हो जाएगा साथ में रहते हैं कर दो line trip यहाँ था dx equal to 2 multiplied by mx फिर मैं इतने x वैल्यू होते हैं dx की वैल्यू होते हैं डिस्टेंस ऑफ x अच्छी करें आयो यतापट्टि 2 आयो यतापट्टि 4 आयो ओके न हाम्रो यति थाहा छ dx को भ्यालु त्यति आउँछ हैन र अब मिनिमम भ्यालु पत्ता लगाउँ अब कसै कसै के छ नि मिनिमम पनि देखिन्छ म्याक्सिमम देखिन्छ मिनिमम भ्यालु कति आउँछ यसको मिनिमम भ्यालु 1 आउँछ यसको मिनिमम भ्यालु 1 आउँछ यसको मिनिमम भ्यालु 7 आउँछ मिनिमम थाहा छ हामीलाई हो कि एक्सन लाग्यो नाउ अगेन अब हामीलाई के पत्ता पर्यो अब हाइएस्ट डिस्टेन्स पत्ता गर्नुपर्छ अब हामीले गरी अब हम पॉइंट बताओगे पॉइंट P app pin app बोला 1 by 2 by 3 का ABS इसको वैल्यू करते हैं एक को वैल्यू अवेलेबल है 1 अब एक को वैल्यू 1 आउँछ भनेपछि 1 फाइन्ड गर्नु एमओ गरौँ mx और अब होइन यो दुईटामा रेफरेन्स चाहिँ एमओ गर्छु त एमओ गरौँ न मेमोरी भइसक्छ एरर आउँछ यता भन्छ अनि त्यसपछि कहाँ जान्छ फेरि एबिएस गर्नुमा एक बेला चेन्ज गर्नु अनि त 2 कुरा हुन्छ फेरि यता 1 छ 1 plus equal to 2 minus 3 एबिएस में 3 आ अब more equal to mx equal to एक बेला अब हाम्रो थाहा छ एक्सन गरेर 3 आयो यता 1 छ अब म को भ्यालु यति 3 enter equal to abs is about I minus equal I plus PIN binary equal to mx a or binary PIN binary this way अब if अब किसमा डिपेंड गर्छ इफ बाइनरीको भ्यालु ग्रेटर छ बाइनरीको भ्यालु के छ भने ग्रेटर इफ बाइनरीको भ्यालु dx भन्दा ग्रेटर छ एन्ड बाइनरीको भ्यालु mi भन्दा नि ठुलो छ CP-31 is called binary index LCIF binary LCIF DSL and binary and dx greater than mi dx value that is count. Let's check this thing. Problem with this one. You already okay. All set. Okay. Use test cases. Does mine. Be the Pinara. Situation was बराबर आने के बराबर आऊंगे हमने बोलेगा बराबर आए वाले नहीं क्या मैं लिखूं बराबर नहीं क्या river is within the forest. Consistency in the status. Okay. Previous answer equal to n max minus median of the previous.
everyone, my name is Viraj, and today we will be discussing the second problem from the CP-31 sheet under the 800 rated questions. Alright, so let's start. I'll of course be moving on to the CP-31 sheet from TLE eliminators. I'll tick off the 800 rated parameter and I can find all my 31 problems over here. So this is our second problem, line trip, and this is a clickable link. Let's go. Alright, so let us read the problem. There is a road which can be represented as a number line. Alright, you're located in the point 0 of that number line and you want to travel from the point 0 to the point x and then back to the point 0. Now you travel by a car, of course, and this car spends 1 liter of gasoline per 1 unit of distance traveled. When you start at the point 0, your car is fully fueled. That means it contains maximum possible amount of fuel. So whatever, let's say, is the capacity of that particular fuel tank, I can say it's fully filled. Now, what are they saying? They're saying there are n gas stations located at points A1, A2, so on to An. When you arrive at a gas station, you fully refill your car. So this is very important. If you arrive at a gas station, you fully refill your car, you go to the full capacity. Now note that you can only refill at gas stations and there is no gas station at point 0 and point x. Alright. You have to calculate the minimum possible volume of the gas tank in your car in liters that will allow you to travel from point 0 to x to the point 0. Great. So this is basically a requirement. I want to get that initial capacity declared as an answer where I think using this capacity as initial capacity or the maximum capacity of my gas tank, I'll do it. Alright, so let us try to generalize and understand this problem. Right, so I'll take up a page over there. So what are they saying that's given us? They are of course saying that there are some points. So I'll call this array A. The points are basically like point A1, then you have point A2, A3, so on till An. So these are the points. And if I try to imagine a number line, so let's say this is my number line. Alright, this is my number line. This starts with the point 0, ends at the point x, and then these points are somewhere in the middle. So they start in order manner, let's say A1, A2, A3, A4, so on, so on. Then you have this A point and then the point x. And then of course you are using a car. So I can draw a car over here, a simple car. This is my car. Okay, this is my car. 2 wheels, and this car initially has a capacity. So I'll call this capacity, this is the gas tank. Let's call this gas tank value as, like gas tank's capacity as C. Alright, now of course there are made some gas stations everywhere. Those gas stations, let's say this is the gas station, this is the gas station, this is the gas station, gas station, and so on, you have a gas station. Now remember, this gas station is not present on the point 0 or on the point x, not present. Now let's try to simulate what the other point is. They're saying, okay, you as a person are going to sit in this car, you are going to travel from 0 to A1, then A1 to A2, A2 to A3, so on, so on, so on. Then An to x, this will be saying I reached from point 0 to x, then back, x to n, An to a n minus 1, A4 to A3, so on, so on, so on, and so on. So this is this green path that you want to simulate. Go from 0 to x, x to 0. Now to do this, we are using a car. Car, of course, utilizes that fuel, that gasoline. So that gasoline is getting used as 1 liter per unit of distance you travel. That means if you travel from 0 to A1, and let's say 0 to A1 has a distance of 2, let's call this distance as 2, that means you will use 2 liters of fuel, and so on. It's very simple, just like saying how much distance am I traveling, that is the number of liters am I using of the gasoline. Alright, so now this is clear in my head. Now what they're saying is, this C capacity should be told by you previously. You know that this C capacity can be some number, it can be let's say 10, 20, 50, so on. What is the C capacity I select, for which this simulation runs perfectly? As in, I don't stop anywhere. I don't stop anywhere. When I say I don't stop anywhere, that means I don't stop anywhere in the middle of the road. As in, if let's say I stop at point A1, I'll be good to go. Because I can refuel. If I stop at point A3, I can stop because I know I have to refuel, or I can refuel. But if let's say you stop at this point, or I'll draw this with the red better. If let's say you are traveling from A1 to A2 and you stop at this point, meaning you are no longer having more amount of gasoline to travel, will you be able to do anything if you stop at this point? Like somewhere in between A1 and A2. It's kind of deserted, right? You don't have any gas station now to refuel yourself, and your gasoline is totally exhausted. Can your car travel anymore? No, you'll be paused. So this is what they're trying to ask. If you're simulating this 0 to x to back to 0 movement, what is that minimum C capacity I select of my gas tank, so that when I simulate this process of refueling everywhere I want, I never stop at somewhere I know I cannot go any further. I want to fully simulate 0 to x to 0 back sort of a travel. Alright, so this is the problem basically. Now let's try to look at this with some test cases. So they are given a test case 3, 7. So that's over here. 3, 7. That means this is basically the number of points. N is 3. Then 7. This is basically saying that x is 7. You can say x is 7 over here. Right? And then the points they have said, x is 7. Points they have said is 1, 2, and 5. So let's try to draw this. This is my number line. 0.7, 0.5, 0.2, 0.1, and this is the 0.0. And then I have a very good car with me, 2 wheels, and I want to travel. So of course the answer to them, let's try to cross-verify the answer. They're saying the answer is 4. That means if this space fuel capacity in this car is 4, then I'll be very good. How? Let's try to simulate. If you have 4 fuel capacity, fully filled right now, you start off, like, I'll call this, let's write this like this. I have the fuel capacity, let's call this as C. This is my current capacity, 4. Now you travel from 0 to 1, you utilize 1 liter of gasoline. So you can say this gets reduced to 3. Yes, because you can say 4 minus 1, that's 3. Now at this one point, can you refuel? Of course, this has a gas station, this has a gas station, let me refuel. So this goes back to 4. Now let's move from 1 to 2. I totally used 1 liter of gasoline. Can I refuel back? Yes, I can refuel back, goes to 4. Then from 2 to 5, alright, this is a very big distance. 2 to 5, 3 liters of fuel. Why? Because you know the distance from 2 to 5, this is 3. So I can say goes down to 1 liter because 4 minus 3 is 1. And then again at point 5, can I refuel? Yes, I can refuel. Back to 4, good to go. Go from 5 to 7, use up 2 fuel. Come back from 7 to 5, use up 2 fuel again. You have 0 gasoline left. But again, because you have reached the point where you can refuel again, go back to 4. Then back distance, go to 3, but refuel again, go back to 4. Go to 1, back to 3, but refuel again, back to 4. And then go to 0, you are totally left with 3 gasoline. And at 0, of course, you don't have a gas station, so you cannot reach the maximum capacity of my gas tank. I'll do it. Alright, so let us try to say 3, so on till An. So on, so on. Then you have the tank value as, like gas tank capacity as C. Alright, now of course, there are made some gas stations everywhere. Those gas stations, let's say this is the gas station, this is the gas station, this is the gas station, gas station, and so on, you have a gas station. Now remember, this gas station is not present on the point 0 or on the point x, not present at all. Now let's try to simulate what they're trying to say. They're saying, okay, you as a person are going to sit in this car. You are going to travel from 0 to A1, then A1 to A2, A2 to A3, so on, so on, so on. Then An to x, This will be saying I reached from point 0 to x, then back, x to n, a to a n minus 1, a4 to a3, so on, so on, so on, and so on. So this is this green path that you want to simulate. Go from 0 to x, x to 0. Now to do this, we are using a car. Car, of course, utilizes that fuel, that gasoline. So that gasoline is getting used as 1 liter per unit of distance you travel. That means if you travel from 0 to a1, and let's say 0 to a1 has a distance of 2, let's call this distance as 2, that means you will use 2 liters of fuel, and so on. Very simple, just like saying how much distance am I traveling, that is the number of liters am I using of the gasoline. Alright, so now this is clear in my head. Now what they're saying is, this C capacity should be told by you previously. You know that this C capacity can be some number. This can be, let's say, 10, 20, 50, so on. What is the C capacity I select for which this simulation runs perfectly? As in, I don't stop anywhere. I don't stop anywhere. When I say I don't stop anywhere, that means I don't stop anywhere in the middle of the road. As in, if let's say I stop at point A1, I'll be good to go. Because I can refuel. If I stop at point A3, I can't stop because I know I have to refuel. Or I can refuel. But if let's say you stop at this point, or I'll draw this with the red better. If let's say you're traveling from A1 to A2 and you stop at this point, meaning you are no longer having more amount of gasoline to travel. Will you be able to do anything if you stop at this point? Like somewhere in between A1 and A2. It's kind of deserted, right? You don't have any gas station now to refuel yourself, and your gasoline is totally exhausted. Can your car travel anymore? No, you'll be paused. So this is what they're trying to ask. If you're simulating this 0 to x to back to 0 movement, what is that minimum C capacity I select of my gas tank so that when I simulate this process of refueling everywhere I want, I never stop at somewhere I know I cannot go any further. I want to fully simulate 0 to x to 0 back sort of a travel. Now let's say this is the problem basically. Now let's try to look at this with some test cases. So they are given a test case 3, 7. So they have said over there 3, 7. That means this is basically the number of points. N is 3. Then 7. This is basically saying that x is 7. You can say x is 7 over here. Alright. And then the points they have said x is 7. Points they have said is 1, 2, and 5. So let's try to log this. This is my number line. 0.7, 0.5, 0.2, 0.1, and this is the 0.0. And then I have a very good car with me, 2 wheels, and I want to travel. So of course the answer to them, let's try to cross-verify the answer. They're saying the answer is 4. That means if this space fuel capacity in this car is 4, then I'll be very good to go. How? Let's try to simulate it. If you have 4 fuel capacity fully filled right now, you start off like I'll call this. Let's write it like this. I have the fuel capacity. Let's call this as C. This is my current capacity 4. Now you travel from 0 to 1. You utilize 1 liter of gasoline. So you can say this gets reduced to 3. Yes, because you can say 4 minus 1, that's 3. Now at this one point, can you refuel? Of course, this has a gas station. This has a gas station. Let me refuel. So this goes back to 4. Now let's move from 1 to 2. I totally used 1 liter of gasoline. Can I refuel back? Yes, I can refuel back. Goes to 4. Then from 2 to 5, alright, this is a very big distance. 2 to 5, 3 liters of fuel. Why? Because you know the distance from 2 to 5, this is 3. So I can say goes down to 1 liter because 4 minus 3 is 1. And then again at 0.5, can I refuel? Yes, I can refuel. Back to 4. Good to go. Go from 5 to 7, use up 2 fuel. Come back from 7 to 5, use up 2 fuel again. You have 0 gasoline left. But again, because you have reached a point where you can refuel again, go back to 4. Then back distance, go to 3, but refuel again, go back to 4. Go to 1, back to 3, but refuel again, back to 4. And then go to 0, you are totally left with 3 gasoline, and at 0, of course, you don't have any gas station, so you cannot refuel. But the argument is, yes, you were able to simulate 0 to x to 0 back. Alright, so I hope the test case has now become very clear. Now let's try to understand the input. So they are saying that test cases would be in 1000. Alright, and they have also said something at the very top that time limit per test case is 2 seconds. Alright, so what do we mean by that? So we can say that I have been given a total of, like, I know that in 1 second basically, I have 10 power 8 operations I can run. Yes, 10 power 8 operations I can run. So in 2 seconds, of course, I will have the capacity to run 2 into 10 power 8 operations. Now, every test case, like for every test case, the time limit is basically, for every test case, you know that you have total of 1000 test cases. Or you can say, not every test case rather, I'm sorry, you can say total number of test cases generally you can say is given 1000. So now if 1000 test cases are there, what about the time per test case? Can you see the time per test case would be basically 2 into 10 power 8 upon 10 power 3, which is 2 into 10 power 5. Now why am I calculating this? This is very important to get an idea of the expected time complexity before I start the problem. Before forming any idea in my head, however I solve the problem, I need to know what's the upper bound on my solution. How far can I go before I think I will get it here? That's the question. So now I know 2 into 10 power 5 is something I can go to an upper extent. Now n, that's given the problem. Let's assume that the time complexity is dependent on n. So can I create a solution that's in O of n cube? Yes, I can. Because n is given in 50 order. So n cube will approximately be, like, it can actually be 125,000, which is like 125 into 10 power 5 order. Now, what is the order allowed? It's 2 into 10 power 5. What is the order you're getting? 1.55 into 10 power 5, which very clearly depicts that O of n cube will surely run. Yes, it will surely run. Now, if O of n cube runs, will anything below this run? Will O of n square run? Yes. Will O of n run? Yes. Will O of n log n run? Yes, it will run. So what does this hint towards me? I know that if I create a solution, I have an upper bound of n cube. So I can maybe write a very brute solution, it will still work. If I create something in n cube. But do I want that? The argument is this. No, I actually don't want that. Maybe if I can, I will create a solution that runs faster than this. But in my head, I know that even if I go to this limit, I'll do it. So this is just to create that idea that when you're forming a code, or when you're thinking of a solution or any intuition, you know you have an upper bound. You have an upper bound to go till n cube order. Right, so I think this is discussed. So I'll write this over here. This is kind of like my expected time complexity. Alright, great, good to go. Now let us start with some observations. So essentially what is if the car covers from A3, this is A2 basically. If you cover a distance from A2 to A3, let's call this as D3. Then what I'll say is, can I say that the distance I will cover from A3 to X and then x to a3 back, so like something like this. Can I say this is going to be d4? Yes, I can say. Why? Because I know I'm not stopping at x because x does not have a gas station. So right now what I've done is I've jotted down the distances of how your car will simulate them. You know, if your car starts off with location 0, like it starts off at this location, location 0, 2 tires. This car, when this starts off at this location, it's very simple that it's going to go from 0 to a1 and it will cover a distance of d1. Then it goes from a1 to a2, covers the distance of d2, a2 to a3 covers the distance of d3, a3 to x to back a3, distance of d4, and then a3 to a2 is again d3, a2 to a1 is again d2, a1 to a0 is again d1. So I'm not writing them back again, but we have a general idea of the distances my car is trying to simulate. Now I know that every unit, like 1 unit of distance I travel, is basically 1 liter. 1 liter of gasoline I require, 1 liter of fuel I require. So if I require 1 liter of gasoline for 1 unit, then can I say this is like d1 units, d2 units, d3 units, and d4 units? Now you have to decide this initial capacity C of your gas tank. Can you say that if you don't want to stop anywhere, you should have at least the minimum, or you can say the maximum of d1, d2, d3, and d4. Whatever this value comes out to be, let's call this value d. Can you say that this d is actually the capacity or minimum capacity, like minimum capacity, minimum C, you require so that you don't process, so you are not able to fully fully cover this simulation from 0 to x and x to 0 back? How? Let's try to think this. If assume, let's say d4 is it's a very large term. Let's say d4 is very large, it's greater than d2, d1 and d3. Now, assume that your capacity C is less than d4. If your capacity C, I'll write this over here. If let's say your capacity C is less than d4, then what happens? Will you cover d1, d2 and d3? You will. But will you be able to cover this d4? No. Because when you will go to cover this d4, you will automatically stop somewhere. You will stop somewhere in between. Because you know you did not have the total net capacity to actually go from a3 to x and back to a3, covering this distance d4. Assuming d4 is the largest amount of d1, d2 and d3. So in my head I know that by common sense, it makes sense, right? It makes sense that whatever is the maximum of these distances, that distance is going to be dependent or is going to make my decision about how much initial capacity should I take. If I take that initial capacity to be less than this maximum, then I know that particular distance, which is actually the maximum, I will fail. Assuming let's say d4 was maximum, I would have failed. Yes, let's go back to the example and understand this very clearly. So in this example over here, what did we see? If you took your capacity to be 4, you would have been good to go. Let's jot down these distances. Can I say 0 to 1 the distance is 1? 1 to 2 the distance is 1. 2 to 3 the distance is 3. 2 to 5 sorry the distance is 3. 5 to 7 to 5 back the distance is 4. Now let's find the maximum. Tell me the maximum of 1, 1, 3 and 4. Isn't this 4? And can I say that the capacity is 4? Right, this makes sense. Now if I would have taken this capacity rather as 3, not 4, then can you say that will you have been able to cover this distance? You require a total of distance 4 to cover. But you only had 3 gasoline of fuel when you would have started from this point. So you would have gone to 7, but coming back you would have stopped somewhere. And yes, you will not have been able to simulate the whole process. This makes sense. Now I know that the maximum distances, like maximum of all the distances, or the middle, like you can say the differences in the positions, which is the middle distance, is what is my answer, is the minimum capacity I require my gas to be. Right, so I'll write this idea fully down. The maximum of the distances is the minimum capacity I need to select, and this becomes my answer. Alright, so I hope the simulation, the problem, and this explanation part has become clear. Now, you can of course take a pen and paper and try to do some manual case checking, and you will definitely realize that yes, by common sense it makes sense. I need the maximum distance. If I don't have a capacity that's greater than equal to this maximum distance, then yes, I will never be able to cover that maximum distance. I will somewhere stop in the middle. My car is going to fail. I will not go from 0 to x to 0 back. So now let's try to look at the code part to actually understand how can we take this idea and implement it, finally get an AC. Right? So I'll open up the code for you. This is how the code looks like. What we'll see over here is you take the input of D, then you take do a while loop in the test cases, then you can take the input of n and x, then I'll create a points vector right now. I don't declare any size to this, and then I push back the first point, that's point 0. So basically I want to simulate this number line. So this is the point 0, I'll push back the point 0 in this. Then I will run a loop from 0 to n, take the input of each and every point that starts coming, a1, a2, a and so on, and I will push back that in the points array. Then at the very end, I will push back the point x because that's the last point I actually want to go, and then I will redeclare my n to be the current points array dot size, which basically means it would be 0 and x getting added, so it's like n plus 2 only, simple. Alright, so I'll say okay, 0 got inserted, x got inserted, now the n size has increased, so I'll just redeclare that part. Now, what is our target? All this d1, d2, d3, we want the maximum of these distances. Can I call these distances as the distances between the points? Yes. So that is what I said. I've taken a variable called max distance between points, and since this has to be max, I'll take initially this to be int min. Now we'll start off with for loop from 1 to n, and what will I check? Is this my last point, which is very important? Is this my point last? That is this point, point x. If that is the case, my distance is not the x and the distance between x and the previous point, but rather double of this. So how do I find this difference? This is basically saying that, okay, x minus whatever is this point a3, and then I want the double. So can I write it like this? I can say, okay, points array of I minus point side of I minus 1. So this is the current point side of I minus what's the previous point side of I minus 1, and the double of that gives me this particular distance, that's d4. In this case, because I know over here the distance is actually double. Traveling from the second last point to x and x2 back, it's the double distance between them. But if there is any other point, I'm starting at any other point, as in a1, a2, a3 and so on, I have skipped the first point because the loop starts from 1. I know that the difference in the distance is simply this point, that's the current point, and the previous point, whatever is the difference, that's actually my distance. So I don't need to double it, it's directly straightforward. So I'll say, okay, the maximum distance between these points has to be maximized with this points array of I minus.
Yeah. Okay, guys. Second question also done. Let's move to third question. See, the code was pretty easy. Last time I did mistake. I just need to use like int equal to max. That's called CZ. What? Called that? CZ. Okay. Okay. Covered in water. Is rolled and has something. क्या बताऊँ मैं अभी? डेटा जीरो जीरो ये तो 5 है 1 2 3 4 3 4 5 6 7 become 4 letting delta in the first test cases Flip can put water in one cell and 3 and cell 2 is between as cell 2 is between 2 cells with water it get filled with water too. Okay. That's your last case. Position number 3. Covered in water. Flip has a row of cells. Some of them are blocked and some of them are empty. We wanted all in the cells to have water and fill them. He has 2 actions to his disposal. And 1. Place water in an empty cell. And has row of cells. Some are blocked, some are empty. We wanted to action and the disposal. Remove water from cell and place it in another empty cell. 3 है मतलब भीतर 4 है 2 है मतलब टोटल 5 है 5 है 2 है अंदर 2 है 0 है 2 है 0 बच्चे 1 2 3 4 5 7 4 in the 50 there exists a sequence of action that will correspond to 2 type 1 action. Remove water from a cell and place it to another. If he has 2 action. 1 place water and an empty cell. And to remove water from a cell and place empty cell. If at some point cell I to is empty and both cell I minus 1 contains water, then it becomes filled with water. If at some point cell I2 lesser or equal to I lesser or equal to n minus 1 is empty and both cell is empty. And both cell I plus 1 contains water, then filled. Find the minimum number of times you need to perform action in order to fill all empty cell. Find minimum number of times in order to perform action 1 in order to fill all empty cells with water. Note that you don't need to minimize the use of action. Note that block cells neither water content nor can fluid place. Note that block cells neither contain water nor can place in water. Each stage is T, the distance contains iron, the number of distance, and the next one contains a string acid length iron, the first is third. If cell is empty or cell is flat, cell blocks it, so it can't do anything. Cell blocks it can't do anything. The first test case is can do. First place water in empty cells. Then this is output a single number, the minimum amount of Now know that you don't need to minimize the use of to note that blood cell neither contains nor can flip water. मतलब blocks container में flipal to minimize the use of oxygen, you don't have to worry about using data messages or performance just around the time movement. Performance into blood cell neither contains before water. They cannot have water inside them, cannot put water from into them either. Fluid cannot put water. So you are completely can compare a partial approximation with the effect. Okay. Now three children. The two questions are the first test case is Filippo can put water in 1 and 3 at cell 2 is between two cells with water. It gets filled with water too. अब यता पनि हामीले के गर्ने हुन्छ 1 and कति हो यसको बीचमा हाल्नु हुन्छ यो अनि एउटा दुईटा फिल्ड हुन्छ 2 भयो यसकोमा 5 अब यसकोमा फिल्ड गर्नुलाई एउटा दुईटा तीनटा चारवटा तीनटामा हाल्नुपर्छ यतापट्टिमा हाल्नुपर्छ 5 यो 0 भयो अब यता दुईटाको चाहिँ हुन्छ भने चाहिँ यता एउटा हाल्यो हुन्छ In the second test cases, we can put water sources in cell 3 and 5. Cell 3 and 5 banda hai. 3 cell, cell 5 cell. The result in cell 4 with water. Then he removed water from cell 5. Place it into cell 6 as cell 5. Cell 4 and 6 have water in them. You can place water cell 5. How's this going, man? How's this going? The number is 3, answer is 2. If any number is odd, the 3, then answer is the 2. No, yeah. 3 में 4 7 को 7 डिवाइड बाय 3 break everything. We cannot go through them. Is continuous group of cells is independent. If a continuous segment of empty cells, the study the line segment length 1 or 2 if you cannot create a middle cell so you need to manually fill every cell. If the segment length 3 plus, you can use one divided to separate the water, similar water, and the two axes. For a long string, you don't need to put water. For a small string, 0 equal, length 0 equal 0. So basically, you CP instead of improving grow. Notice how the problem is not about simulation of single tasks when you trying determining the formula yourself. Code and numbers to implement. This one is some good pattern to remember. 0, 0, 1, length 1, 1, length 2, 2. For any consecutive that segment of length 3 or more, you only need two initial water placement. 3 go like 2 cents. Once you get a pattern key notice your answer 0, 1, 2, 3, 4, 5, 6. Yellow 0 cents. Yellow 4 cents. Yellow 3 times cents. Yellow 3 times cents. और 4 उड़ा वाला 3 बार आंसर और 3 टाइम 4 करते हैं वो करना 2 टाइम 3 टाइम 4 करते हैं वो डाले बात में तो ये लाइन में करने वाला 3 टाइम 5 ड्राइव होते हैं 1 2 3 4 5 ये लाइन डाले उधर बदला इधर बदला you can done by statement 15 by statement 2 statement done by तो 3 statement होता है 3 statement you can work you can try 4 statement 6 वाला 1 2 3 4 5 6 मतलब वाला you can work तो इस पे चीज़ होगा 3 step 2 step हम लोग लगाता है ಎಲ್ಲ ಇದ್ದಾರೆ ಇವನ್ ಮಾಡ್ಕೊ ಸಾವಿರ ಸ್ಟೆಪ್ ಕಂಪ್ಲೀಟ್ మనం till 3 till k equal to lesser is equal to 2 it required n. Answer will be 2, answer will be n. Again, for the 3, answer will be cow k minus 2. K minus 1. equal to 4 answer answer because after placing water in two positions you can move answer 0. If they have 1 and 2 intercept and the number of intercept called length of current. Current increase group and process current not restricted to 0. Process current not restricted to 0. Process 0. Reset. Current 4. To do. For every character, if use current. After loops use current. Power in water. Power is in water. Use current.
everyone,
My name is
remove
Viraj,
water from a
and
cell
today we'll
and
be looking
place
at
it
the
in
third
any
problem
other empty from the CP-31 sheet. Now what
by
is this
TLE
given is that
eliminators
if
under
at
the
some
800
moment
questions.
cell I,
Let's go.
so I'll
That
move
is
on to
I
my belongs to
CP-31
sheet
sheet
over there, and I have ticked off my 800 weighted parameter, and I have the third problem, cover in water. Alright, so let's click on this. Okay, let's read. Philippe has a row of cells is empty and both cells I-1 and I+1 contain water, then it becomes filled with water. Now you have to find the minimum number of times he needs to perform operation number 1 in order to fill all the empty cells with water. Note that you don't need to minimize the use of action 2, and note that the block cells neither contain water nor Philippe can place water in them. Alright, so let us try to generalize the problem. What are they asking over here? Okay, so what will they give you is, I think they will give you a string. Alright, they have said that I'll give you an integer n, and then I have a string, and then if I have a dot, it's an empty cell, and if I have a hash, it's a block cell. Okay, so let's try to imagine this part. I will have n size over here. So I have n size with me, and that n size will be used to denote basically a string. So I have a string s, and I will have the characters s1, s2, s3, s4, s5, so on till sn. These are the characters that I'm going to have. I have taken a 1 base indexing, alright, so 1 to n, not a problem. Now I have basically, like, every character is representing some every s1 to sn is basically a character, and that character is out of 2 characters only. I'll define them over here. Either it is a dot, which means it's empty, or it's a hash, which means this is, you can say, blocked. Okay, so I'll just take an example. Let's say I have some example string that looks something like this, like dot dot dot, let's say hash, and let's say one more hash, then let's say one dot hash dot 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 hash hash, something like this, just for example. All right, now what it is saying is blocked or hash means a place where there is no water. Okay, you're talking about something as cells and you're trying to fill something that with water. So I'll take this with blue pen over here. You have something like a water, and blocked cell or a hash cell means it's basically, you can say, a wall, or it's basically something which is null and void to you. You cannot do anything over there. Which you can do is actually at places of empty cells. So if let's say I have these 3 dots and this 1 dot, 1 dot, 4 dots again. So these are kind of my empty cells where right now there is no water. Alright, there are some space given to me, but there is no water right now in them. Now, I have 2 operations given to me. Alright, operation number 1 is I can fill empty cell with water. This is operation number 1. And what is operation number 2? Operation number 2 is basically saying that if, let's say, I have some cell filled with water. Okay, if I have some cell filled with water, I can remove it and move it to some empty cell. So basically this water can be taken and it can be moved to an empty cell. Okay, so now let's go ahead with some diagrammatic representation. Okay, very simple. Again, point number 1, there is an empty cell, dot. You say, oh, I manually take my hand and fill this with water. Now I have W over here. That's water. This is my manually filling. So you can call it something like this, that this was empty and you filled it with water. And what is operation number 2? Let's say there was some place that was there which was filled with water, and let's say there was some other empty cell which was not filled with water. Manually, diagrammatic representation. Okay, very simple. Again, point number 1, there is an